Alright, this is my video for the CSC 480 8 puzzle project. I'll start by running the code to demonstrate that it works. So if I run my main program, prompts me for a level, I'll select easy and B for breadth first search. It outputs the moves and then the statistics. I could run it again and this time select hard, for instance, for my custom A3 search, and it will again output the moves and then a set of statistics. So now to the code. I used one class just for the main loop of executing the program, which will prompt the user for which level he or she wants, and then prompt for which algorithm. And then each algorithm is represented by, has its own class, and we'll call the start method in that class. Later on, we'll see how the output of calling the start method is stats that will be used for the output back to the console, and that stats has its own class of a statistics class. So how I modeled the 8 puzzle, I said that the most important thing is the state. The state is the representation of the tiles and their positions within for a certain state. And the constructor of that can take a one-dimensional or two-dimensional array, and it will actually have properties for both because sometimes I found one more convenient than the other to work with. The state also maintains some helper properties such as where the zero is in columns and rows, for example. The successor method, in order to generate children, you don't generate them on initialization of a state because that would be inefficient. You only get them when you need them. So to call the getNextStates method, what it's doing is it's returning an array of the next possible states, and it says which moves are possible, up, down, left, and right, by determining what would be, if I wanted to move up, that means my row would decrease by 1, assuming the top row is indexed at 0, and it's saying, is it still within the bounds? Is my row still 0, still greater than -1, if I were to decrease that row, for instance, for moving up, and you can imagine what the rest of them would do. The node class is what maintains a state and represents a position in a tree. So the fact that it represents that position in the tree means that it has children, it has parents, it also is what's responsible for calculating costs that will be used in some as our heuristics and in some of the other algorithms, like I've used real cost as what's actually happened so far rather than the estimate costs. Now to the different algorithms. Like I said, each has a class, and they start with, for breadth first, we would use a queue, for instance, because we want first in, last out. And to represent the states that we've seen before, we use a hash set. So state objects can hash themselves into a string so that it's a lot faster to compare, have we seen these before, just look if it's in the set, rather than having to loop through an entire array of state objects and compare the actual states themselves. We continue in this while loop until we find a winning node, and each time we pop a node off the queue, we say get its children and then put those children onto the queue. So it's pretty simple for the breadth first search. It'll change in some of the other ones, like for instance iterative deepening. What we have to do is we have to actually check the depth, and if at any point we've checked all the nodes that we can at a certain depth, we increase the depth by 1 here. So if the current node that we're looking at is equal to the max depth, we know that it's time to increase the depth there. Or if our stack has gone to 0 because all the children, for instance, are things that we've seen before. That was a little trick that got me caught up. Maybe another one that's interesting to look at would be one of the A stars. So for those, for instance, we need to, like some of the other algorithms, we need to compare if we've seen these things, even if we haven't seen these things before, is the cost less than the thing that we have seen before? So it's doing that down here. I'm running up on 5 minutes, so I'm trying to be quick. You'd use a stack, for instance, for the depth first instead of a queue because we want first in, first out. What else is there? Oh, my heuristic was a weighted Manhattan distance. So what that means is it's Manhattan distance, but considering that each move is not 1, it's actually equal to the tile number times that distance. So it takes into consideration more the cost of each move. And that is all the time I have. I think that covers everything. So I will stop it.